Hello and thank you for watching the first lesson in Chapter 2. Woo! Solving one-step equations. So the objective today is to solve one-step equation variables. This is really the basis of algebra. And we're going to be doing this throughout this whole year. You'll be doing this in geometry. You'll be doing this in Algebra 2. So it's really important that you understand these concepts. If not, please ask a question. Before I get into how to solve these are your thinking process. And the thinking process I will always state while you're solving this problem is what math, so adding, subtracting, dividing, or multiplying, is happening in the equation, and what is the opposite of that math, because you have to know both in order to solve a problem. So just to refresh your memory of the opposites of your four basic math operations, and you probably already know them, but I make sure to write down this thinking process in your notebook. If I check your notes, I will make sure that you have this in your notebook. Opposite of adding would be subtracting. Opposite of multiplying is dividing. Opposite of subtracting is adding. And opposite of dividing, that should say dividing, is multiplying. So opposite means, how would I undo this? That's like the opposite. So I just wanted to show this. You do not, repeat, do not write this down. This will just hurt your hand once you write down all this stuff. But I want to go over it. We have the addition property of equality and subtraction property of equality. Basically, what's that saying is I can add or subtract something to any equation, and as long as I do it to both sides of the equation, it doesn't change any results. This would be like if you were surfing in California and you need to be balanced on the surfboard. You have to make sure to keep your weight balanced in order to stay up. Otherwise, you go down and the wave takes you under. And it's the same thing for subtracting. As long as you subtract the same amount on both sides of the equation, it doesn't change anything. So let's get into some problems. Again, you should always be thinking, what's my thinking process? The first question you're asking is, what math is going on here? Here, it's adding. And then the next thing you think is, how do I get rid of adding? Or what's the opposite of adding is subtracting. So now I know I have to subtract. Whatever you do one side, you have to do the other. If you want to draw a line down, you can. I don't always do this, but that keeps it separate from one side of the equation together. Now, what do I want to get rid of on both sides of the equation? My main goal is to get this x all by itself because I want to know what is x equal to. So I know I have to subtract. And if I want to get rid of the adding 13, I would want to subtract what's shown. And what's shown is my 13. So I'm going to subtract 13 from both sides of the equation. Remember, surf. So on the left-hand side, these two will cancel each other out. They're already gone. 13 minus 13 is 0. So I'll just have x on the left-hand side is equal to 27 minus 13 would give me 14. So now that my x is all by itself, this would be my final answer. And that's it. So now I'm looking at my next equation. And right away, I'm going to just draw my line. Remember, when you're on your surfboard, you want to keep balance. You want to keep your left and right side of your equation balanced. In my thinking process, first thing is, what math is going on here? And if I look, I'm subtracting. So the opposite of subtracting would be adding. So now I know I have to add to both sides of the equation. And what do I want to get rid of? I want b by itself, so I want to get rid of the 3. So I'm going to add 3 to both sides. On the left-hand side, negative 7 plus 3 would give me a negative 4. And on the right-hand side, negative 3 plus 3, those will cancel out, and I'll just have b. If for some reason you ever have a number still with your variable, something went wrong and you should try to solve the problem again. Otherwise, this would be my final answer. B is equal to negative 4. And as you can see on both of these equations, it doesn't matter which side of the variable is on, you can still solve no matter what side the variable is on. So now I want you to try. So right now I want you to pause and try to solve the two equations and then check your work. So your two answers you should have gotten was m is equal to -6 and y is equal to 2. As you can see with my first equation, I had subtraction because whatever happening to the variable is what you have to do the opposite of. I have subtraction, so the opposite of subtracting is adding. You have to do both sides of the equation, and I get m as -6. For the other side, I have subtraction, so I have to add again. So this time I'm adding 3/2, and I showed how to add fractions just in case you forgot. You have to show work. You cannot just do this on your calculator. You have to show work. I get 4/2, which is also equal to 2. Now it says to check your answer. If I want to check my answer, I'm going to put what I found as my answer, so -6, back into the original equation. So here I would have -6 minus 8. And when I do -6 minus 8, that is equal to -14. So that checks out. Yay! So if I look at my next problem, if I want to check my answer, I have 2 minus 3/2, which is equal to 1/2. And that checks out. Yay! I'm so happy. Do not write this down. This is just to go over to show you. Same as multiplying same as adding and subtracting, when I multiply and divide, as long as I do it to both sides of the equation, it is okay. You have to keep it balanced like your surfer. Whatever done to one side has to be done to the other. So when I'm solving these problems, my thinking process is still the same. My first step is to say, what math is happening here? And when I say here, I mean with the variable. So if I were to read this question out loud, it says 4 times x. So I'm dealing with multiplying, and I think the opposite of multiplying would be dividing. So now I know I have to divide on both sides of the equation. Again, whatever you do to one side, you must do to the other. So if I'm going to divide by something, I want to get rid of this 4, so I'm going to divide by 4. If I divide by 4 on one side, I have to divide by 4 on the other side. This step right here, I would say you can use your calculator if you wish to. And you would get x is equal to 1.6. And that would be my answer. If you want to check your work, you can put it back into your original equation to see if 4 times 1.6 gives you 6.4. Now for my next problem, again, your first step is to say what math is going on here. And you always look at the variable. When I say what math, you look at what's happening to the variable. Right now I can see it, x is being divided by 4. So I have to think, what's the opposite of dividing? That's multiplying. So in this step, I want to multiply. I'm going to write it out again, just so it's easier. I'm going to multiply this side by 4. So whatever I do to one side, I have to do to the other. And 4 times x will cancel out these 4, so I'll just have x on the left-hand side is equal to -9 times 4. I know it's going to give me a negative, and negative times a positive is negative, and that would be a 36. And this would be my final answer. Again, if you want to check your work, you plug it back into the original to see if you do -36 divided by 4, is it -9? I want you to pause right now and see if you can solve these next two problems by yourself. So now if you check your work, you should get that r is equal to 57 and x is equal to -72. Above is where I put, this is what's happening, so the opposite, I want to do multiplying for both problems. And with both problems, I multiply by whatever number it's getting divided by. So 3 times 19 is 57 for the first problem, and 8 times negative 9 is negative 72. These next two problems might seem a little tricky, but they're not. It's the same thinking process. When I look at my first problem, I have to think, what math is happening? Well, this right now says 4/5 times m. So what's the opposite of multiplying? That's dividing. So if I rewrite out this problem, 4/5 m is equal to 28. So I want to divide on both sides of my equation. And I'm going to divide by whatever number is in front. So I'm going to divide by 4/5. Now this is where what we've done in class should help you. Dividing by a fraction is the same thing as multiplying by its, that's right, reciprocal. So I'm going to multiply by 5/4, and I'm going to simplify before I multiply. So I can simplify the 28 and 4, because 4 goes into 28 7 times, and then I'll have a 1 below. So now I have 7 times 5 is equal to 35, and 1, because this would be over 1, times 1 is 1. So m is equal to 35. I want you to do the next problem by yourself and check your work. So your answer should be 16. If it's not, then you should follow along with me. So I rewrote the problem above, and I saw that the math happening was multiplying, so I was going to divide. And I divided by 3/4 because that's the number that's being multiplied by x. Well, I know that multiplying by a fraction is the same thing, or dividing by a fraction is the same thing as multiplying by its reciprocal. So the second fraction, it flips. And in the purple, I simplified before I multiplied. So I simplified my 12 with my 3. So that became 4 and 1. So as I multiplied across, 4 times 4 is 16, and 1 times 1 is 1. So my answer was 16. So now I have the question, are the equations m equals 18 and 2/3 m equal 12 equivalent? And how do I know? Right now you should pause and try to solve this problem yourself. Well, if I want to see if they're equivalent, the first thing we want to do for the second equation is solve for m. So I'm going to rewrite 2/3 m is equal to 12. And the first thing I do in my thinking process is say, what math is happening here? It's being multiplied, so the opposite of multiplying is dividing. So it's being multiplied by 2/3, so I'm going to divide by 2/3 on both sides of my equation. Divide by 2/3. Remember, whatever you do to one side, you must do to the other. These two will cancel each other out. So I'll just have m on the left-hand side. But now I have 12 over 1 divided by 2/3, which is the same thing as multiplying by 3/2. I'm going to simplify before I multiply across. 2 and 12 being simplified to 6 and 1. So now I can multiply across. 6 times 3 is equal to 18. 1 times 1 is equal to 1, which is 18. Now I can compare the two equations. My equation that I solved, m is equal to 18. In my original equation given, m is equal to 18. So are they equivalent? Equivalent means equal. So I could say, yes, they are equivalent. And how do I know? I would say, look at my work. Work shown. And that is it for your first lesson in Chapter 2. Remember, if you have questions, make sure you're asking in class. Otherwise, have a wonderful day, and I'll see you tomorrow.